Welcome to Video 3, Session 3, the characteristics and benefits of a database. So why databases? So we need to access data and quite often resort to data for various uses. We may have to sort it, we may have to process it, and we need to create mailing lists, we need to capture information, we need to write reports, generate certain lists, identify various client needs. These are examples of reasons why we want to use a very specific and organized database. The processing power of a database allows it to manipulate the data it manages. So it can easily sort, manage, link, match, aggregate, skip fields, calculate, arrange. Most databases, most relational databases are very flexible in their queries. So in order to extract the data we need, most databases give us a very powerful query system that allows us to shape the data in almost any way that we need it. Because of the versatility of databases, we find them powering all sorts of projects and applications. Databases are the backbone, typically, of a website. We may hear the term web server. Interestingly enough, nothing is ever stored on the web server. The web server is runtime only. All data is saved on the database. So if we want any kind of client tracking application, social media, medical records, personnel and personal address for email, a collection of word process documents, or a system that issues airline reservations, are all powered by different databases. And the characteristic of a database approach, a database system contains not only the database itself, but also descriptions of the data and constraints. This is often called metadata. So metadata typically can be defined as attributes. So an employee and the employee's address. So the address is an attribute of the employee. Sometimes you hear metadata described as data about data, and well, that is true, but quite often it's better to have an example. And this information is used by the DBMS product or the database users if needed. So essentially, we can look up the metadata about the different entities that we're tracking in the database. So this separation makes the database system totally different from the traditional file-based systems in which data definition was part of the application program. And there is an insulation between the program and the data. In a file-based system, the structure of the data files is defined in all of the application programs. So if a user wants to change the structure of a file, all the programs that access those files may need to be updated. On the other hand, in the database approach, we use a structured or a data structured way to store it as a system catalog. That way, all programs will still access the data in the same way in which they were configured to access the data. And for the characteristics of the database approach, they can support multiple views of data. So a view is a subset of data which is defined as dedicated for a particular use or users in the system. So a view could be something as simple as the results of a query. Multiple users in the system might have different views of the data in the system. And hence our query example, not every user is going to see that result set. Each view might contain only the interested data of the user or the group that's accessing that data. Absolutely true. And then sharing of the data with a multi-user system. A multi-user database system must allow multiple users to access the data at the same time. As a result, the multi-user DBMS might have or must have the concurrency to control strategies to ensure that several connections can be made to access the data at the same time. And there are all kinds of strategies to optimize the database, including a replicated database system where there is one read-write node, we'll call it a node for right now, and then it's coupled with a group of read-only databases that are exact replicas. This optimizes the load and performance of the database system. And benefits to the database approach to control data redundancy. So in the database approach, ideally each data item is stored only in one place. However, in some cases, redundancy still exists to improve system performance, but such redundancy is controlled and kept to a minimum. That's like that example we just discussed, where we use database replication, and that's often a feature with most database systems, or it can be an add-on, where a replica is created and is constantly updated with the read-write node or the master node. Also, data sharing. The integration of the whole data management in the organization leads to the ability to produce more information from the given amount of data. And really, when we share data and we're able to view that data differently, it does result in an enhanced amount of information sharing or information gathering for the same data. And databases also enforce integrity constraints. So databases can enforce types, so integers, dates. So that way, no corrupted data can be entered into the database. And also, databases have user access. So we can control who has access to the system, who can read the system, and who can write to the system. So DBMSs should provide a security subsystem to create and control user accounts. And when we say control user accounts, we mean role-based type of accounts. So who can read data, who can write data, who can update data, and who can delete data. And also data independence. So the system data descriptions are separate from the application programs. They're almost layered on a different tier. So changes to the data structure is handled by the DBMS and not the embedded program. So again, this allows that independence. So any application can use standard ways to access that database. And also transaction processing. The DBMS or database management system must include a concurrency control system to ensure that several users trying to update the same data do it in a controlled manner so that the result of the updates is correct. So databases have a way of actually locking the data so a transaction can be completed by one user before the next transaction is started by the next user. Also providing, again, the multiple views of the data. So a view is a subset of the database. Various users may have different views of the database or the data itself, and users may not need to be aware of the way that the data is stored and referred to. So a query, a result set, sometimes an update. These are all examples of different views of the data. And then also providing a backup. In the event that the host fails, the hardware fails, that data must be recoverable, and it must be stored in a place where it can be easily recovered and again restored to online processing.